volume. So this one we talk about volume of solid, which is just the amount of space it occupies. Now, much like surface area, the volume of solid, I think it's actually a pretty simple formula. It's just area of the base times the height. So that's what's going on here, right? You find the area of the base, and then you fill it up by multiplying by the height. Same thing if it's a triangle. Find the area of the base, fill it up by finding the height. That's kind of it. So even these, like volume times width times height, I don't even think about that. I just think about its area of the base, and then times it by the height. Same thing here, right? They have this formula. Why is it that formula? Because the area of the base, in this case, is a circle. Then you times it by the height. That's all it is. So let's do an example real quick. So I want to find the volume of this. So I'm going to find the area of the base. I've only said it 4 times in a row. Now in this case it's a circle, so that's pi r squared. And then times by the height, which in this case is 45. Now r here might have a diameter is 36, so it means my r is 18. So pi times 18 squared times 45. So I'm probably just going to use a calculator for that. So 18 squared times 45. So I get 14580 pi. Now IB usually accepts that, or if you want, you could times it by pi, if it's a calculator portion of the IB exam. And you get that much messier. So something like that. Okay, next one. It's a triangle. I don't know why I said it's kind of funny. So it's gonna be the same idea. It's always the same. Area of the base times the height. Remember, the base is always the things with the parallel sides. So the base here will be the triangles. Now the height is this guy. Like put on its side, that's the height, 30. Now I gotta find the area of the base. Now it is a triangle, so it's gonna be 1/2 base times height. Now let's see how it's an isosceles triangle. So my base is 12, and I'm gonna make my height this straight line right here, like that. Since I cut it in half, that makes it side 6, and we could do a triangle that looks like this. Not my best triangle. 6, 10, and I don't know what that is. Remember, by the way, this height's different than that height. This is like the height of the whole thing. This is just a squared, b squared, c squared. Anyway, different heights. So I can actually solve this triangle, but it's a fairly famous triangle. It's a 6, 8, 10 triangle. It's a classic Pythagorean triple. 6, 8, 10. Just like you should know 3, 4, 5 the triangle, right triangle. 5, 12, 13. These are all right triangles you should kind of know. We should kind of know. Like this is 6, 8, 10. Right? If you squared it, you get 36 plus a squared equals 100. 100 minus 36 is 64. Square root of 64 is 8. So that is my height. So area of this triangle would be 1/2. 8 times 6. Actually, my base is 12. Sorry. Right, the base is the whole thing. So 12. So 1/2. 8 times 12. Well, this is 4 times 12, so 48. So 48 times 30, I could do that. And we get this. So that's the volume of this prism. If I want to find the volume of the cylinder, if you notice it's a cylinder inside a cylinder. So what I'm going to do is do the area of the volume of the whole cylinder and then subtract off the volume of the inside cylinder. So let's go out cylinder minus n. So same thing, area of the base times the height minus area of the base times the height. Now the height for both of them is 4.6. So I mean I could factor it out if I wanted to. Area of the base, these are circles, so pi r squared. So the radius of the big circle, well 2.4 is the whole thing, so the radius must be 1.2. So pi times 1.2 squared times 4.6 minus inner circle, right? The radius is 1.6, so the diameter is 1.6, so the radius must be half of that, which is 0.8. So it's going to be pi r squared, but pi times 0.8 squared times 4.8, 4.6. If you really want to, you can factor out the pi and the 4.6, and it's really just 1.2 minus 0.8. We'll multiply by that. So that would work. I'm just going to put my calculator, solve this. So pi times 1.2 squared times 4.6 minus pi times 0.8 squared times 4.6. And I get 11.561. So this would be one where they would definitely do 3 sig figs. Something like that. Meters cubed. By the way, if we're doing volume, volume is always cubed. Area squared, volume's cubed. So there's that one. Next one. Find the 3 sig figs. The radius of a cylinder with a height of 3.9 and a volume of 54.03. So this one's a little backwards, right? That gives the volume. So we have to know how to find the volume, which is area of the base times the height. Now my height is 3.9, so there that goes. My base is a circle, so the area is pi r squared. So I'm going to have 54.03 equals pi r squared times 3.9. Right, and all they want to do is find the radius. So let's divide by pi, divide by 3.9, and take the square root. So let's divide by pi, I guess. I don't know why I'm doing that first. I'm going to use my calculator, my handy dandy calculator. There we go. So 54.03 divided by pi. And I get 17.198-ish. R squared times 3.9. Now again, even here, you know, right here, like I rounded it there. On my actual answer, my calculator, I'm not changing. I'm gonna use the value I have. So divided by 3.9. Right, you don't do 3 sig figs till you get your answer. That's when they want 3 sig figs. So divide this by 3.9. And I get, let me move this so I can see my work. 4.49816, and then we square root it. And r would equal the square root of that. Which would be 2.099956. 3 sig figs will be 2.10. So there we go. It's the radius. Okay, tapered solids. All that means is, as you can see here, when it's like, I always say it's pointy. If you could stab somebody with it, it's a tapered solid. And it's the exact same formula. Hey, look at that, I use my formula now. Finally, area base times height, except that this is actually only a third of a full thing. So a third of a full prism, a third of a full cylinder. So it's just 1/3 area base times height. So if you could use that as a murder weapon, then it's just 1/3 area base times height. Only difference. And then spheres, just a formula. 4/3 pi r squared. So let's do an example. So if I want to find the volume of this, volume equals 1/3 because it's pointy. Area of the base times height. So area of the base, now it is a rectangle, so I'm just going to multiply 5.1 times 2.3. And the height is 6.8. They can't make it any easier. You just plug it in. Okay, that's too easy. I'm just going to let that go. I'm not even plug it in. It's not worth the time. And then spheres are just easy, right? The volume is 4/3 pi r cubed. So I'll watch out. They actually use the radius, not the diameter, because that's what this is, right? They're showing the diameter. So my radius is half of that. That's 9.1. So 4/3 pi times 9.1 cubed. Again, just put that in your calculator to get the answer. It is volume, so it would be cubed. And that's pretty much it. I think that's it. Yep.